Assalamualaikum and a very good day everyone. My name is Nurul Ain binti Yazid, final year student in Chemical Engineering UiTM Shah Alam. And I am excited to share with you my research project on the physicochemical characteristics of food waste charcoal briquettes using natural binder. Under the guidance of my respected supervisor, Associate Professor IR Dr. Siti Shawalia Idris, and with the honor of having Dr. Jeffrey Jabbar as my examiner. In this presentation, the goal is to discover sustainable solutions within the field of solid waste management. Now, let's proceed to the research overview. In this section, we will delve into the essential components that form the foundation of my study, which includes introduction, literature review, methodology, and conclusion. These elements collectively highlight my research journey from its inception to the anticipated outcomes. The global phenomenon of wasting 1.3 billion tons of food each year is both concerning and troubling. These numbers highlight an urgency for action and systematic change. According to 2012 report, Malaysians were producing 33,000 tons of solid waste per day, which is significantly more than 30,000 tons predicted to be produced by 2020. This overproduction of solid waste presents a significant challenge for the nation's waste management infrastructure and sustainability initiatives. Therefore, utilizing food waste to produce charcoal briquettes is an unconventional solution to address two essential global concerns, which are food waste and sustainable energy. This sustainable strategy repurposes organic materials that will otherwise be disposed of as waste. Food waste comprising organic materials like leftover fruits and vegetables, meat, and chicken bones serve as the primary raw material for the production of charcoal briquettes. However, the briquettes were distinct from the charcoal briquettes utilized nowadays in terms of shape, quality, and manufacturing technique. Thus, two notable methods highlighted in manufacturing technique are traditional charcoal production and microwave pyrolysis. Each method presents its unique set of advantages and disadvantages, influencing the overall outcome of the charcoal briquette production process. But microwave pyrolysis method offers the advantage of faster processing times and potentially more controlled conditions. Thus, this method is the most effective method in food waste charcoal briquettes manufacturing. Aside from that, the binder has been developed as a result of prior research and has been recommended for use an alternate method for improving the quality of food waste charcoal briquettes. The efficient use of these food waste charcoal briquettes relies heavily on the precise selection and application of suitable binders, such as used cooking oil and banana peels, which play a crucial role. Each binder will be combined with charcoal briquettes of varying concentrations, allowing for the determination of the chemical and physical properties of the food waste charcoal briquettes. My research project begins with a fundamental question. What is the problem I aim to address? In my case, I am confronted with three problem statements, which are tree felling, which known as conventional techniques for charcoal manufacturing, contributes environmental impacts. Lower caloric value, which consequently contributing in a reduction of overall energy content in charcoal briquettes, as well as reduction in hardness of charcoal briquettes due to the lower concentration of binder. Thus, by identifying these three problem statements, it serves as a guiding force for the entire research process. The objectives could be determined once the problem statements have been determined. There are two primary objectives in this research. The first objective in this study is to investigate the effect of different types of binder, in which banana peel and used cooking oil, on physical and chemical characteristics. And the second objective is to determine the impact of binder to food waste ratio of 1%, 5%, 10%, and 15% on the physical and chemical properties of charcoal briquettes. Now, let's proceed to the scope of research. In this section, it outlines the specific parameters and limitations that engage my research. There are three scopes of research. The first one is focused on collecting food waste from a nearby cafe, which located at Dataran Cendekia UiTM Shah Alam. Food waste collection should be done within 1 to 2 days. This time frame is essential to safeguard the freshness and quality of collected food waste, which both act as critical factors in maintaining the research precision and reliability. The waste collection will primarily target pre-cooking waste, encompassing discarded materials generated prior to the cooking process, such as meat, vegetables, and rice. Second scope is specifically concentrated on the utilization of binders with a focus on banana peels and used cooking oil. The sourcing of these binders involved collecting banana peels from a nearby stall at Section 2 and acquiring used cooking oil from a restaurant within the same area. The collection process is strategically planned with a 2-day time frame to prevent the deterioration of banana peels and potential contamination of the used cooking oil. And the last scope is a comprehensive analysis of charcoal briquettes could come across limitations due to the detailed composition of the raw material and the intricate interactions among organic components throughout the conversion process. The limitations arise from difficulties in precisely quantifying particular chemical constituents, potential fluctuations in complex interaction of different compounds in the raw material, which hinders an accurate assessment of the end briquette product. Utilizing advanced techniques such as CHNSO analysis could significantly enhance the determination of the chemical composition and structural characteristics of the briquettes in enabling to overcome these challenges. The term food waste refers to the act of disposing of or throwing away edible food that has not been spoiled and is still safe to eat by humans. It may happen at any step along the food supply chain, including production, processing, transport, retail, and the level of the individual consumer. Approximately 76% of the items were deemed edible, such as bones and fruit peelings, while the remaining 24% were considered consumables such as leftover meat and vegetables. This level of waste contributes to Malaysia's overall food waste problem. The improper management and disposal of discarded food waste make significant damage to the surrounding ecosystem. Inefficient management of food waste and food loss stands as a significant contributor to the emission of potent agent of roughly 3.3 billion tons of carbon dioxide. Addressing food waste is therefore imperative not just for environmental sustainability, but also for fostering social equity and economic resilience on a global scale. To address this issue, food waste offers a diversity range of possibilities for its conversion into various valuable products, illustrating its potential for reuse and resourcefulness to reduce its impact on environmental, social, and economic. Technological advancement have further broadened these possibilities by introducing innovative uses for food waste in developing new food products, bioplastics, and ingredients for cosmetic and pharmaceuticals. Charcoal briquettes prevail as a preferred choice across diverse applications owing to their distinct attributes and inherent advantages. Their extensive application arises from unique characteristics that include efficient combustion, consistent heat output, prolonged burning duration, and ease of storage, as well as transportation. These qualities position charcoal briquettes as versatile and practical options for industrial process and environmental applications. Charcoal briquettes are a compact and compressed kind of charcoal that is frequently utilized for both cooking and heating, serve as practical kind of charcoal. Charcoal which usually generated from wood or other organic materials are compressed into a uniform shape with the aid of a binding agent and additive to produce these products. Good properties of charcoal briquettes include a uniform shape and size, high density, minimal moisture content, low ash product, durability and handling, and a consistent burning rate. The history begins with charcoal briquettes originated in the early 20th century. The creation of charcoal briquettes as a product originated from the need to discover a productive use for the excessive wood and sawdust produced by the lumber milling industry. Utilizing sawdust and scrap wood, E.G. Kingsford invented a method to produce limited briquettes in the form of pillows. After a period of time, the company that was once known as Fort Charcoal changed its name to Kingsford Charcoal Company, consequently establishing its reputation as a well-recognized manufacturer of charcoal briquettes. Henry Ford concluded that recycling these discarded materials into charcoal briquettes will be an effective way to solve the problem. However, it is possible that the effectiveness and widespread application of charcoal briquettes may be allocated to their particular physical characteristics. The effectiveness and adaptability of charcoal briquettes have led to their widespread use in many different fields, such as households, industries, and emergency situations, highlights its significance as a reliable and diverse fuel option like grilling or cooking. In the context of charcoal briquettes, the term binder refers to a substance that is incorporated in the production process of briquettes in order to bind the charcoal particles together. It provides the function of an adhesive agent which helps to ensure that the briquettes are cohesive and preserve their structural integrity. There are three types of binder, include natural, inorganic, and composite binders. Each type of binder plays a vital role for different applications. However, the main factor that contributes to structural integrity of charcoal briquette is concentration of binder. This table illustrates various applications achieved through the use of different binders in the production of charcoal briquettes. Through comparison on the binders, the best binder is organic binder. Organic binder are derived from natural sources and include materials such as starch, molasses, lignin, and other organic compounds. Natural binders fall under the category of organic binder when classifying binder used in the production of briquettes. Natural binder is commonly used in the production of charcoal briquettes to create a sustainable and eco-friendly alternative to synthetic binders. Hence, natural binders, specifically banana peel and used cooking oil, have been selected to facilitate the production of charcoal briquettes from food waste. Microwave pyrolysis technique is a modern and inventive methodology for the manufacturing of charcoal. The process involves the use of microwave radiation to induce thermal reactions that result in the heating and decomposition of organic substances, leading to the formation of charcoal. Microwave pyrolysis is recognized for its heating speed. The appliance has the capability to rapidly convert organic substances into charcoal within a short time frame, thereby exhibiting a high level of efficiency and adaptability for application requiring small-scale or expedited manufacturing. Aside from that, microwave pyrolysis allows for precise control over temperature and heating, resulting in consistent charcoal quality and reduced emissions. Beyond its role in enhancing product quality, this method contributes substantially to environmental preservation by mitigating the release of harmful gases and pollutants. By precisely regulating the pyrolysis process, this technology minimizes the environmental impact associated with briquette production, in which aligning with eco-conscious industrial practices. In this research, there are 5 analyses might be considered. The first analysis focuses on the moisture content. Moisture content of the charcoal typically falls in the range of less than 10% throughout the entire process, based on previous research. This equation indicates the determination percentage of moisture content where initial and final mass of charcoal briquette sample will be considered. According to this table, manufacturing of charcoal briquettes from various feedstocks results in a moisture content of less than 10%, which may be deemed appropriate for use as charcoal briquettes. In terms of moisture content, charcoal briquettes made from food waste are the most practical as they are ideal for purposes like grilling and have the lowest moisture content. Lower moisture content often results in briquettes that burn for longer durations. Proceeding to the next analysis, which is caloric value. Charcoal briquettes possesses a high caloric value, typically between 7,000 and 8,500 calories per gram, as they comprise primarily of carbon based on previous study. The high calorie value of this energy source provides both efficient fuel consumption and broad adoption in home and industrial applications, which make it a stable and effective choice. Open ignition. This carbon-based substance undergoes combustion, resulting in a discharge of a substantial quantity of heat energy per unit of mass. According to the data provided in this table, coconut husks have the greatest caloric value due to the fact that they contain a significant amount of carbon, which is a high-energy substance. Nevertheless, its caloric content remains lower than the standard range of caloric value observed in charcoal briquettes. Thus, this study aims to use specific binders to enhance the caloric value of food waste charcoal briquettes in addressing the previous issue. Next, third analysis will focus on compressive strength. It refers to the ability of the briquette to withstand compressive force without breaking or crumbling. It is a crucial property that influences the performance and durability of the briquette during handling, transportation, and use. High compressive strength is generally desirable in charcoal briquettes to ensure they maintain their form and functionality by considering several factors, such as composition, binders, drying time, and compaction process. Next analysis to be considered in charcoal briquettes is shatter index. The shatter index of charcoal briquettes refers to the susceptibility of the briquettes to break or shatter under specific conditions. It is a measure of the briquette's resistance to impact or external forces that may cause it to disintegrate into smaller fragments. A low shatter index indicates better resistance to breakage, which is desirable for charcoal briquettes to maintain their structural integrity and effectiveness during combustion. Manufacturers and researchers often evaluate the shatter index as part of the quality control measures to ensure the reliability and performance of charcoal briquettes in various applications. Last analysis is combustion properties. The combustion properties of charcoal briquettes encompass various factors, and the burning rate is a key parameter among them. The burning rate refers to the speed at which the charcoal briquette combusts or consumes during the combustion process. Understanding and optimizing the burning rate is essential for the efficient use of charcoal briquettes, especially in applications like cooking or heating where a consistent and controlled burn is desired. Now, let's advance to the next chapter, where we'll begin by examining the general procedures employed in this study. This chapter encompasses a detailed discussion of the techniques utilized throughout various stages of the research. It provides insights into the methods applied for obtaining and processing feedstock samples comprising food waste. The procedure sequence commences with the preparation of raw materials. Following preparation, the carbonization process is initiated by employing microwave pyrolysis technique. Then, subsequently, a grinding process undergoes carbonization to reduce the size of charcoal briquettes into smaller particles. The preparation of binders, such as used cooking oil and banana peels, as well as the mixing process, ensure to enhance the structural integrity of food waste charcoal briquettes. Moving forward, the briquetting process shapes the briquettes into cylinders with specified dimensions using a 20-tone molding apparatus. Subsequent to shaping, the briquettes undergo a microwave drying process lasting 2 hours for thorough dehydration. Upon completion of the drying process, food waste charcoal briquette is done. For a physical test, several experiments will be conducted to assess the effects of various binder materials and their proportions on the compressive strength, shatter index, and moisture contents. Firstly, the compressive strength of the briquette is evaluated using a universal tensile testing equipment, following the usual testing procedure. Then the drop shatter index method was used to assess the durability of charcoal briquette formed when subjected to repeated impact during handling and transportation by implementing drop shatter. The test begins by ascertaining the weight of each briquette using a weighing scale. The samples underwent a repeated dropping process in which 2 times from a height of 2 meters onto a concrete floor. A charcoal briquette was placed on a designated area for the sample, and a progressively increased force was applied at a consistent rate until the sample fractured or shattered. Then the moisture contents of charcoal briquettes by utilizing moisture analyzers will be determined. This equipment, also known as moisture balance, which is specialized instruments designed for accurately measuring moisture content in solid samples. This device typically uses a heating element to evaporate moisture from the sample, and the loss in the weight is used to calculate the moisture content. For chemical tests, several tests will be conducted for determining the caloric value, proximal and final analysis of the produced samples. The caloric value is measured following the ASTM 2015-96 standard using the bomb calorimeter. Another analysis was conducted following the guidelines of ASTM 537302 using the CHNSO analyzer to determine the elemental composition of the samples. TGA is used to analyze the combustion characteristics of the samples. The samples are exposed to a dynamic temperature heating process. This process was carried out under oxidation condition utilizing filtered air. The combustion characteristics including ignition, peak and burnout temperatures will be documented. Utilization of food waste as a feedstock combined with eco-friendly binders address environmental concerns and yields briquettes with favorable mechanical strength and combustion characteristics. Aside from that, employing natural binders, specifically banana peel and used cooking oil, able to produce valuable insights into a sustainable approach to waste utilization. The utilization of natural binders not only addressed environmental concerns by repurposing food waste, but also highlighted the potential of banana peel and used cooking oil as effective binding agents. This eco-friendly alternative to conventional briquette production also not only enhances the structural integrity of the briquettes, but also contributes to a more sustainable and circular economy. Their comprehensive study encompassed the application of microwave pyrolysis during carbonization process. As we go through these general procedures in methodology, the resulting charcoal briquettes able to demonstrate promising physicochemical attributes. The findings of this research encompassing physical and chemical tests which provide a foundation for eco-conscious waste management practices and also offer promising avenues for the broader adoption of food waste charcoal briquettes in sustainable energy solutions. As we advance towards a more environmentally responsible future, this study contributes essential knowledge to the ongoing discourse on waste to energy technologies, thus emphasizing the potential in enhancing the physicochemical characteristics of charcoal briquettes derived from food waste. I think that's all from me. Thank you.